The second problem is about a town called Namche Bazaar, which is at the foothills of the Everest. In this problem, there are 1,200 beds in the village, and the climbers on average stay for 10 days. And the question asked how many climbers arrive on each day to sustain this. Well, this is a very interesting little stop problem. Okay, so Little's law says I equals to RT. Well, if there are 1,200 beds, and if you think of this town as a process, or this people coming into the town as a process, and there are 1,200 beds which are always occupied, right? If there are no beds, obviously there's not going to be somebody. There are no new climbers, right? So there are 1,200 beds; they are already occupied. That means at any given time the inventory is 1,200. That's easy to see. The climbers stay there for 10 days. That means the time between climbers entering the system and coming out of the system is 10 days. So what we need is the rate. To sustain this, how many customers should arrive every day? Well, if we have 2 out of the 3, I equals to RT, I equals to 1,200. We need to find R. T is 10, so R is 120 climbers per day. So that is, if there are at any given time there are 1,200 climbers and each of them stay for 10 days, that means to sustain that there must be arrival of 120 climbers every day. That sounds pretty logical. Alright, the next question is, now this is the real operations part. The next question is just basic algebra. The question says, on the arrival, the day the climber arrives, he spends $50, and after that, for the remaining 9 days, he spends $30 in the local restaurant. Okay, that means what is the total expense? So this is the, call it old world. In the old world, what is happening is the first day you spend $50, and remaining 2nd through 10th day you spend $30. Now what they're saying is, instead of staying there for 10 days, the climber stays there only for 5 days. In new world, and again the same thing stays. On the first day he spends $50, 2nd through 5th day he spends $30. One crucial assumption here is it's still always booked. The first thing we want to find out is what is the rate. What is the rate if the climber stays, the flow rate if the climber stays only for 5 days? Well, again the same idea, I equals to RT. I is still 1,200, the number of bed hasn't increased. We're after R, T equals to 5. R equals to 1,200 divided by 5, that is 240. After that, so that is this 240 climbers per day. Now we are ready to calculate the total money the town makes each day. So in the old world, what happens is 120 climbers arrived, are the new climbers for the day. For 120 people, this is their first day. So they spend 120 multiplied by 50, and remaining 1,080 people, 1,200 minus 120, they spend $30. So altogether, they spend $38,400. What's happening in the new world? In the new world, well, there are 240 people. It's their new day. It's their first day, right? So 240 multiplied by 50. Remaining 960 people, that is 1,200 minus 240, that is 960 people, they spend $30. So this is altogether, they spend $40,800 per day, right? There's a slightly trickier way to do this problem. The rather niftier way, I would say, the way is this, right? In world, what's happening is an average tourist who stays for 10 days, he spends $50 on the first day, and for remaining 9 days he spends 30 days, spending altogether 320 days, right? So on average, every day he spends 320 divided by 10, that is, on average he spends $32 each day. Whereas in the new world, what happens is the first day he spends $50 and remaining 4 days he spends $30, altogether spending $170. But on average, he spends 170 divided by 5, that is $34. So an average tourist or average climber each day spends $32 in the old world and $34 in the new world. But there are 1,200 average climbers. 1,200 multiplied by this difference of $2, that is $2,400. The same answer we got here. 40,800 minus 38,400 is 2,400. Here also the gap is $2,400. So in the new world, the town makes $2,400 more. Let's finish the second problem too here. And this is kind of I like this second problem. It's a very interesting problem. What's happening here is this Summer Sweets has a revenue of 4.3 millions with a COGS of 2.6 millions. This gelato store always has 4.5 days worth of inventory. The question is, what's the inventory turn? Well, even if you just understand the definition of what's inventory turn is the number of the times you flip your inventory. If you flip your inventory every 4.5 days, how many times you're going to flip it? So let's do it in the formula way. Inventory turns is 1 over T. But remember, inventory turn is always expressed in terms of number of times per year. So our T is expressed in terms of days, so we have to convert it in terms of year first. So 4.5 days, to convert this in terms of year, all we have to do is multiply by 365. It says take 365 days per year. So if our T is 4.5 divided by 365, 1 divided by T is 1 divided by 4.5 divided by 365. This is 365 divided by 4.5, which comes out to be about 81.4 days. No, 4 times, sorry. The next question says, given that he has a 4.5 days supply on average, how much inventory does Summer have on average in terms of dollar? Now, I like this idea because most of the little flow always focuses on flow rate and flow time. People never focus on inventory as something we might not know. But there are scenarios where you might not know how much inventory you have and you really want to know. In most of the cases, I understand that why people think inventory is given. Because, well, in any business, you want to know the inventory, just count it. Right? Look at your computer, how much stuff you have on yourself, that's your inventory. But think about a business which you want to expand, or think about a new business you want. You really want to know how much inventory you're going to hold in terms of dollars, because that's a working capital. You might have to take the money as loan for the working capital, or you want to know how much money am I going to lose if I burn my store in terms of inventory. So that in those cases, you really want to know your inventory in terms of dollars, right? So let's find it, right? Inventory in terms of dollars, again, I equals to R times T. We know our R is, again, remember, flow rate, whenever it's rate, in all these calculations, we always want to use COGS, not the revenue. We know our rate is 2.6 million, 2,600,000 revenue, this dollars per year. Now we want to find our T. Again, remember, given our rate is in terms of year, we have to have our T in terms of year 2. That is 4.5 divided by 365. That's our T. Well, you do the math, it comes out to be 32,400 $32,054. So at any given time, you have $32,054 worth of inventory in his shop.